Hello? Hello?
No.
Okay. Yeah, let's move that. I think we are all together with regard to question number Roman figure 2.
Which Roman figure number 2, Mr. Ndo?
Question A, Roman figure 2 from 2013 question paper.
Okay. I don't have question papers. I have nothing.
Oh, okay. Yes, is this one? The one we're doing. It's
Okay.
Yes. Okay, let me go to question number 2, which is about to show that the following matrices.
So whenever the question says reduce using the row echelon form, we must find the 0 below and above the diagonal.
Very true. That is what we're supposed to do.
Even though it's a 3 by 3 or 4 by 4.
Yeah. Even if it is 3 by 3, 4 by 4, you must.
Okay.
So now we're going to do another interesting question here. So it says show that the following matrices are inverse to each other, of each other. So we're given matrix 3, 5, 1, 2, and a matrix 2, -5, -1, 3. So this is what we do if you want to show that matrix, the two given matrix are inverse to each other. You must multiply them together. So when you multiply them together, they must give you an identity. Are we all together?
Okay.
Yes. If you want to show that the two matrices are inverse to each other, when you multiply them together, they must give you what? An identity. Which identity is in this form?
Okay.
Yes. So now let's multiply and see if we're going to get the identity. And because we are showing it must be true that we must get the identity. Otherwise, if we're not getting the identity, it means there's something wrong that we did. Let's multiply these two matrices. In order to get the first entry, we multiply this with that. So it's going to be 6. It's going to be 6 minus 5, which is 1. Did you all see how we obtained that one?
Yeah, I know it's 3 times 2 plus 5 times -6. Minus 1.
Yes, exactly. And then from there we do the same. We multiply the first row with the second column. So it's going to be 3 times -5 multiplied by 5 multiplied by 3, which is what? What is the entry there?
Mr. Ndo?
What is the second entry here?
I'm having a bit of a network. So we are going to say 3. We are going to say. Are we going to say to use 3 or we're going to use 1?
We're going to use 3.
3 by -5 plus 5 by 3.
Which is what?
3 by -5 is gonna be 15 plus 3 by 3 is gonna be 9. And then we are adding -15 and 9. So we're going to have what?
No, it's 15 minus 15.
It's 15 minus 15.
Yeah, because it's 3 multiplied by
Oh, yeah. 0.
What? 0. Let's do for the next component then.
Mr. Ndo,
What do we get for the next component there?
we are going to use 1. 1 times 2 plus 2 minus 1. We're going to get 0.
It's going to be 0 there. And then for the last one?
1 by minus 5 plus 2 by, we are going to get 1.
And what is that?
Identity.
Therefore, we have showed that this and that are inverse.
Okay. Oh, once they gave us an the identity, it means they're inverse.
Very true. Rodents.
Yeah, we are together.
Let's go to the next question. This is about showing. Wait, let A be equal to 1, 3, 2, 1, 2, 2, and then B to be 0, 3, 1, negative 1, negative 1, 0. Can you tell me the size of this matrix A?
Mr. Ndo?
What is the size of matrix A?
2 by 3. 3 by 3. 3 by 2.
It is 2 by 3. That's correct. And this?
This one is 2 by 3. Iman, it's 3 by 2.
3 by 2, ne?
Yeah. What did the question say on this one?
Let me go to the question just now. The question said, check as to whether or not the product of AB and the product of BA are defined. This is what we want to check. We want to check if the product of AB and the product of BA are defined. Are we all together? And this question, it's also said explain fully. So we need to explain fully. But for sure in mathematics, we explain mathematically. So it's going to be AB equal to, what is A? What is the size of A?
It's 2 by 3.
It's 2 by 3. And then the size of B?
It's 3 by 2.
Is 3 by 2. So therefore, if these two values are the same, it means the size of AB is going to be 2 by 2. You take the outside ones. You see that?
Okay.
And then let's do the same for AB. For AB, we're going to have B, which is 2. The B is 3 by 2. And then the A is 2 by 3. Therefore, the size of BA is going to be 3 by what? 3 by 3. You see that?
Yeah.
So, but the question said explain fully. So it means we're supposed to show how it's going to be 2 by 2 and how it's 3 by 3. So, but we know AB is going to be 2 by 2 and BA is going to be 3 by 3. So let's explain fully. This will be our last part for the day. So AB, we're going to substitute the A, which in this case is 1, 3, 2, and 1, 2, 2. And then the B, which is 0, 3, 1, negative 1, negative 1, 0. So we multiply these together. So when we multiply this together, what I want you to get We multiply this with that. It's going to give us what? So it's going to be 3 minus 2, which is 1. And then we multiply this with that. It's going to be 3 minus 3, 0, and then 0. So it's going to be 0 there. So this with that is going to be 0, 2 minus 2, which is going to be 0. So this with that is going to be 3 minus 2, which is 1. Do you see how we get to the answer?
Yeah.
Yes, exactly. Just have to multiply the 2. And you can see the answer we got is the 2 by 2 matrix, of which we proved that we're going to get the 2 by 2 here. So the next one, the answer we're going to get for the next one is, it must be what? 3 by 3. Let's see if we're going to obtain the 3 by 3. So it's the multiplication of BA, not AB. So for the BA, it means we're going to have 0, 3, 1, negative 1, negative 1, 0, and then 1, 3, 2, 1, 2, 2, of which when you multiply this, is this with that. So it's going to be 3 for the first one, this with that, it's going to be 6, and then this with that is going to be 6. And for the second one, is this with that, which is going to be 0, and then this with that is going to be 1, and then this with this is going to be 0. And for the last one, this with that is going to be negative 1, this with that is going to be negative 3, and then negative 2. So that's the 3 by 3 matrix that we are looking for, and is the proof that we wanted to get.
Okay.
Yes, so that's how we prove. We show, because the question says explain fully. This is the explanations we have given, but the solutions that they wanted is this. The size of AB is 2 by 2. The size of BA is 3 by 3. Therefore, the size of this matrix, they are defined.
Okay, Mr. Ndo.
Yes.
Ndo.
That.
Abadambuza, ila kubusa yana ya mbrao nyana. Ilamba, kori, find the determinant using row reduction. Above to the below and above the diagonals, sir.
Yes, we find the zeros below diagonal and then multiply the components on the diagonal.
Oh, we find zeros below the diagonals only.
Yes.
Multiplier diagonals rawan answer yao.
Yeah, exactly.
Okay. No. I Lola Rabundo covering. Even what was sure as Rota na mishumo yo dara man.
Adizoku.
Marandgolibu Wabundo, the first time I met you, I didn't know anything, but now I'm for a guide. They are going to find a bona and what guy.
Yeah, no, it's the chimbira.
No, not one amount of Bondo would have seen that.
Okay, I'm not in game.
Da.
Dando.